All right, let's dive in. Something really fundamental is changing in the world of artificial intelligence. For the longest time, the race was all about one thing, size. But that's not the case anymore. We're seeing this massive pivot to a totally new kind of AI, one that's all about being smarter, not just bigger.
And that really leads us to the big question, doesn't it? When we're talking about AI, is bigger really always better? This is the one question that's forcing the entire industry to completely rethink its game plan. Okay, so let's break down what's happening. The old way of thinking was pretty straightforward. Just build these gigantic models, throw more and more power at them, and hope for the best. The new way? It's all about building AI that's super efficient, that has much better reasoning, and packs it all into a smaller, smarter package. So how did we even get from point A to point B? Well, it all kicked off with what you could pretty much call an AI arms race. The whole idea, the dominant philosophy, was that to make AI more powerful, you had to make it physically larger. Just keep cramming in more and more of these internal variables, or parameters. But yeah, that approach hit some pretty serious walls and fast. We are talking about just massive computational costs. It is incredibly expensive to train and run these behemoths. They guzzle a staggering amount of energy, and they completely depend on these huge centralized data centers. It just wasn't sustainable.
And here it is. This was the real turning point. Researchers slammed into a wall called diminishing returns. What they were finding was that doubling the size and the cost of an AI model, well, it wasn't coming anywhere close to doubling its performance. The improvements were getting tinier and tinier for each massive, expensive leap they took. Something had to give.
And that's exactly what happened. This problem led to a whole new philosophy. Let's build AI that's smarter, not just bigger. This is all about focusing on efficiency and real capability, instead of just brute force and raw size. So what does that actually look like? Let's start with the first key idea here, denser. Okay, imagine trying to learn a new subject. You could use a library filled with messy, disorganized, random books, or you could use a single, perfectly written, concise textbook. A denser AI model is like that textbook. It packs way more useful knowledge and capability into a much smaller space because all its internal connections are just more effective. And the second key idea is smarter. And look, this isn't about the AI just memorizing more trivia from the internet. Not at all. This is about real reasoning ability, the power to solve logic puzzles, to actually think step by step, and to follow complex instructions. It's a huge shift from just retrieving facts to something that feels a lot more like actual intelligence. Right, so the million-dollar question is, how are they actually pulling this off? What's the secret sauce that's making these new models so darn efficient and intelligent? Well, one of the coolest techniques is called model distillation. Just think of it like a teacher-student relationship. You have a massive, super powerful teacher model that generates these perfect, high-quality examples and literally shows its work. Then a much smaller student model comes in and just studies those examples to learn the patterns of how to reason. And the result? The student can think just like the teacher, but at a tiny, tiny fraction of the size and cost. It's pretty elegant. Another huge piece of the puzzle is a total shift in the data they use. Instead of just dumping the entire messy, redundant internet into the AI, developers are now curating what they call textbook quality data. It's filtered, it's clean, it's organized. This lets the AI learn concepts way more efficiently instead of wasting all its time trying to find a clear signal in all that noise. And there are other really clever tricks in the bag too. One is called mixture of experts. Think of it like your brain having a team of specialists. So instead of the entire AI model firing up to answer your question, it just activates the one specific expert it needs. That saves a ton of energy. At the same time, they're constantly optimizing the algorithms, improving the core math so these models can handle complex stuff without needing more memory. Okay, so that's all some cool tech, but what does it actually mean for you, for us? Because this isn't just some abstract shift happening in a lab somewhere. This pivot has direct, tangible benefits. And it's all about putting powerful AI right in your pocket. The payoff for us is just huge. We're talking about way faster interactions with things like chatbots, with a lot less of that annoying lag. We're talking about the ability to use powerful AI tools on your phone even when you're completely offline. It means better battery life for our devices, and because these models are so much cheaper to run, it could very well lead to more affordable AI services for everybody.
But honestly, maybe the most profound change, the real game changer, comes down to one simple fact. Because these new models are small and efficient enough to run locally, right there on your phone or your laptop,
Your data never has to leave your device. It stays with you, on your machine. This is a massive, massive leap forward for privacy because your personal information isn't being sent off to some company's central server just to be processed.
But of course, no technology is perfect, right? This new approach, as promising as it is, has its own unique set of strengths and weaknesses, and these are what's shaping the road ahead for AI.
So it's really important to get the trade-offs here. On the one hand, yes, you get superior reasoning, amazing efficiency, and way better privacy. But on the flip side, these smaller models, they can't memorize as much random trivia. They also have smaller context windows, which just means they have a shorter memory for the conversation you're having. And here's a big risk. If they're trained only on perfect, clean data, they can sometimes struggle with messy, real-world problems. Oh, and if that big teacher model has a flaw, you better believe the student is going to learn that same error.
And all of this leaves us with a really fascinating final thought to chew on. As we look to the future, which path is actually going to win out? Are we going to rely on a few colossal AI brains that live in the cloud? Or are we moving toward a world with a billion small, efficient, and private AIs running in all of our pockets? That's the real question this whole pivot is asking, and the answer is going to define the next chapter of technology for all of us. Thanks for tuning in.